Okay.
So, shall we start, sir?
Yeah.
Okay. So, participants, with great pleasure, I introduce Mr. ASHISH Mehta, sir. Sir is currently working as a Vice President Technical Services at Luthra Group of Industries. Is a professional with over 2 decades of experience in the field of environmental engineering. Sir has done bachelor's degree in chemical engineering from Shivaji University, MTech in environmental engineering technology from BITS Pilani, postgraduate degree in business management from IIM Calcutta, postgraduate program in environment, health and safety from UPES Dehradun. He has a comprehensive understanding of designing, erecting, commissioning, operating, and maintaining various facilities, showcasing proficiency in managing complex processes, systems, and regulatory landscapes associated with environmental engineering projects. Mr. Ashish Mehta is a distinguished expert known for his extensive knowledge and profound insights into hazardous waste management, wastewater treatment, energy audit, cleaner production, EHS, sustainability, integrated management systems, circular economy, and ESG practices. Sir, we are overwhelmed to have you as a speaker for this session. Over to you, sir.
Thank you. Is it audible?
Yes, sir, it is audible. You can start the presentation mode.
Okay. I hope my screen is visible.
Yes, sir, it is visible.
Fine. Very good evening to all the participants. Uh, Today we are going to have a brief interaction on basically concept of CETP and ZLD. We will first discuss about the concept of CETP and ZLD system. What is the current scenario in our country? The associated environment impact when we are facing the challenges of untreated wastewater streams. What are the prevailing regulatory frameworks? How the standard schemes are applied for CETP and ZLD systems? And what are the innovations going on? And after this, I will represent a case study for our common effluent treatment plant that we are operating and maintaining at Surat, which is dedicated for textile industries and also having ZLD system. So this is the brief content what we are going to have. I hope the slides are changing and it is visible. Can you please?
Sir,
No, sir,
can you make it on presentation
presentation
mode
mode.
Yeah,
slide show?
just a minute.
You need to start the presentation mode, sir.
Already I have made it.
It is
Let me do it again.
okay, sir.
Can you see the screen now with
Yes,
presentations?
your screen is visible.
Hmm. Let me
Yes,
again go into the presentation mode. I hope it is visible.
yes, now it is visible.
And it is moving also.
Yes, yes, it is moving.
Okay, so to start with, uh, these are the contents I discussed. Okay, we will have an discussions on concept of CETP ZLD with regulatory framework. What are the uh, key components in the system, the innovations, and then we will have a case study of our own GETP CETP, which is catering to textile sector here in Surat. So to start with, uh, the concept of CETP had come into the early 80s, where the community-based projects were required to provide support to small and medium-scale enterprises. Small and medium-scale enterprises has certain limitations in terms of technical know-how, in terms of financial aspects, and also in terms of regulatory compliances which they need to meet. So common effluent treatment plants are basically community-based project which can cater to number of industries present in a cluster. Maybe it is having similar kind of industry sector or maybe the processes. So common effluent treatment plant basically supports on this area to this kind of industries. Currently in India, we have uh, more than 80 numbers of CETPs, uh, large and small, basically, particularly catering to different industrial sectors. Also, there are number of STPs. They are also providing this kind of community projects, but it is for a different application. Now, if we talk about what is zero liquid discharge, the zero liquid discharge system aims at recycling and reuse of the wastewater which is generated with series of value addition and processing and recovering maximum amount of water for the next set of operational processes. So here ZLD plants ensures elimination of liquid water discharge to any surface water bodies. Now, why there is a need for ZLD for CETPs? CETP handles diverse and complex kind of fuels. It helps in basically control in pollution levels, which would be going for further deterioration of rivers and groundwaters. It helps basically to achieve the environmental norms and meet the compliance. And many of the times, it helps in resource recovery apart from water, salt, and energy also. So, if we summarize the key concept of ZLD for CETP is that we have to cater the industries with technical know-how and commercial aspects. At the same time, eliminate the liquid wastewater discharge by recovering maximum amount of water, more than 95%, and address the challenges of pollution associated with rivers and groundwaters, and also to achieve the stricter environment norms. Definitely, salts and energy, water, these are the resource recovery aspect. Now, if you see, this is the map of our country representing water stress across different states. Uh, you can see that most of the states are representing the stress level in the range of 40% and on higher side. We can see the dark red color and then moving towards orange and yellow. So 50% of our country is facing water side. This is the projection and data which is available from World Resource Institute. India has 18% of population with 4% of freshwater resources, and per capita availability is around 1486 meter cube. This has been down from earlier 5000 meter cube per year in 1950s. So the thing is that the water source availability is gradually decreasing. 21 major cities are expected to run out of groundwater by 2030. These are the Niti Aayog report, and we are already saying in the period of summer, many cities, many states are going through this extreme water shortage moment. The maximum surface water body or maybe groundwater is consumed for agricultural purpose, but industry also contribute a significant amount, which is in the range of 8 to 10%. So total fresh water is used for this industrial applications. So this is again linked with the overall water need and water resource management. Now, what is the scenario on wastewater generation? Total wastewater generation is around 72,000 million liters per day, where industrial wastewater contribution is roughly 13,000 mld, that is around 18%. Out of this, we have only 16% of industrial waste treatment facility available. That means even today, if these data are of year 2023, so 40% of our industrial water is still untreated or partially treated, which is causing the pollution. So this is the genesis and basis for wastewater treatment and its recycle reuse by following the ZLD approach. Now, if there is an untreated effluent, what are its impact? 70% of our surface water is contaminated. 62 million Indians are affected only by nitrate pollution. These are the data associated with groundwater contamination. There are issues related to health impact generated from waterborne diseases, cancer, and other illness. Economic cost that we are paying, that is 7.7 billion annually in US dollar, as per the World Bank report. So the pollution has the impact on environment. They are not only degrading our nature, they are also polluting our freshwater resources and creating negative impact on health and our commercial activities, because it has economic impact at a greater and larger length. So what is the solution and what governments and statutory bodies are doing basically? So there is a regulatory framework under Water Prevention Act 1974. Then there is Environment Protection Act. Then there are basically guidelines prepared by Central Pollution Control Boards for ZLD. And there are several orders by National Green Tribunal or for basically ZLD implementation. If you have gone through the chronology of basically last 7 to 8 years, NGT has got very stricter for implementation of ZLD. And this is because there are several industrial clusters which has fall into the critically polluted area, and there are basically perennial rivers where the water quality has degraded a lot. So for the regeneration of those rivers and rivulets, NGT has issued several orders for ZLD implementation. So this is the basis that many of the industries and clusters are forced to adopt the ZLD concept. Industries, particularly in water scarce region, have no other option to go for ZLD because there is no other water source available. There are issues related to key sectors which are highly water intensive. Their need for water is very high. Such are basically textiles, tanneries, pharmaceuticals, and chemicals. And ZLD mandate is very well adopted to a certain extent by states like Gujarat, Tamil Nadu, Rajasthan, and Maharashtra. We have initiated, but I would say there's a long way to go. But this is the ZLD mandate status right now in our country. Now, If we talk about CETP and ZLD, then what are the key components? So for any common effluent treatment plant having ZLD, the components can be divided into 5 parts. The first part is pre-primary and primary treatment. Second is secondary treatment. Third is tertiary treatment. Fourth is evaporation, and final is crystallization. If we talk about primary treatment, it covers screening, equalizing, and neutralization. In primary process, our intention is to reduce the suspended impurities and provide sort of physicochemical removal for the turbidity, suspended solids, color, oil and grease, and other associated impurities. In secondary treatment, we provide biological process with the help of biomass and bacteria. We degrade the organic load of the effluent and remove the impurities, remove the pollutants and contaminants. So here, all the effluent treatment plant or maybe CETPs have adopted this scheme, and they are meeting the statutory norms for surface water discharge. But if you want to now differentiate and if you want to go into the ZLD system, then the third and the most important step comes is tertiary treatment. Also, it is recognized as polishing treatment. So for that, we have to go into the advanced filtration, which includes ultrafiltration, which includes micron filtration, which includes reverse osmosis and other similar processes. Here we are basically removing all the impurities, including the dissolved solids. After this, there is a process of evaporation. So whenever we get into the tertiary treatment, after that we generate amount of reject. That reject needs to be further concentrated by means of solar evaporation, by means of multi-effect evaporator, or by means of new technologies like MBR system. And finally, there is a crystallization where all the remaining concentrated liquid is converted to salt and solids. So in nutshell, these are the 5 important things or components for any CETP ZLD system or the process. If we, you know, try to represent it in a standard schematic scheme, it could be like this: that we have a receiving tank followed by a pre-settling and equalization, where the screening will take place, where the sedimentation process will take place, and the homogenization of the effluent will take place. In common effluent treatment facility, the major challenges which is faced is basically variation in organic load and variation in hydraulic load. So the variation in hydraulic and organic load can be partly addressed by equalization and homogenization. Then comes the physicochemical treatment process. Here, dissolved air flotation system or different kinds of clarifier where the flocculation process can be carried out with the help of coagulants and uh, polymers. In this process, primary sludge is generated, and then the primary treated effluent is subjected for secondary treatment, which includes basically biological treatment process. In this biological, there could be activated sludge process, there could be MBBR, there could be cyclic activated sludge system, and so on. In this process, we have to provide biomass, the organic load, and the air for their survival and biological degradation. After the biological treatment, it can be further subjected to advanced filtration, as we mentioned in third stage or the third step. Here, there could be different kind of micron filters, followed by ultra filters, and different stages of reverse osmosis. Stage 1 from the reverse osmosis can be fed to the stage 2 and finally to the stage 3. So from each stage, the permeate is separately collected and rejected is transferred to the next stage for maximum water recovery in the range of 90 to 95%. The treated water or the permeate can be recycled and reused for industrial application, and whatever reject has been achieved is concentrated with the help of multi-effect evaporator or mechanical vapor recompression system and converted to salt. Whatever salt and solids are generated is finally disposed of in secure landfills. So this is how basically schematic of CETP and ZLD plant looks. Now, depending on the type of effluent, depending on its type of characteristics and the industry sector, these schemes are basically modified and customized to the need of the project. Now, what are the benefits of ZLD system? The first benefit is that we can recover maximum water, that is more than 95%. There is a resource recovery. We can recover salt, chemicals, and energy. In tannery sector, in textiles, there is a recovery of basically brine solution. There is recovery of global salt. There is basically recovery of dyes and pigments also at a smaller scale. So these are the possible options when we go for ZLD system. In dairy industry, ZLD system is also providing valuable product which was earlier being discharged into the river. So these are the potential, resource recovery benefits from the ZLD system. The environment protection is that we are not discharging any wastewater to the water bodies. So it is helping in preservation of those water bodies, meeting the stringent regulatory standards for compliance, because we are not dependent on any surface water bodies or the groundwater, and we are not extracting, or we are extracting on a lower level. It helps in improving the groundwater quality, and ultimately the industries which are heavily dependent on water, it ensures sustainable development. It helps for the entire region in regenerating the rivers and supporting the Swachh Bharat mission initiatives. The important thing which I would like to highlight here is that for basically small units or a single unit to achieve this compliance is very difficult, because they have lesser experience and lesser technical understanding. They don't have necessary resources. They couldn't focus on their core business, and there are issues related to cost effectiveness. So when you go for a community project, when you go for a larger capacity plant, whether it is CTP or a ZLD system, these are the direct benefits to industries. You can achieve cost reduction. You can focus on your business because somebody on the other end is taking care of wastewater treatment and recycling. There would be no issues and botherations on statutory compliance because somebody else is taking care of your effluent treatment. There is an expert team who is handling the issues related to ZLD and CETP system. There are available resources which has been taking care of basically ZLD system. So these are the benefits, and obviously there is a consistent quality of water available at the industry doorstep, and it helps them basically grow and have sustainable development. These are the benefits of CETP ZLD system. Now comes, what are the challenges? Key challenges in implementation of ZLD system is basically high capital and operational cost. All the recycling and ZLD system are very energy intensive process, because here we are completely eliminating discharge of water, and whatever is generated we are converting it to final solids, maybe by evaporation and treatment. So definitely these are the energy intensive process. This process has newer technology, and there are challenges associated to the we need technical expertise. That is another challenge. Then there are challenges related to sludge management and disposal. And there are issues related to resistance from industries due to cost concerns. Because ZLD and the associated processes are costlier, it has basically issues from the industries. Now, if we say what would be the costing approximately on the capex and opex part, so roughly these are basically our observation and analysis, a general idea. There would be a capital investment required anywhere between 50 to 100 CR for a 10 MLD of plant. There would be an operational cost anywhere between 100 to 200 rupees per meter cube of treated water. This includes the cost of CETP as well as the cost of ZLD system till the evaporation of salt. And the payback period would be around 7 years, depending on the type of water quality and the resource recovery or the ZLD concept has been adopted. Now, what is happening in the ZLD technology arena? Now, the recent development is focus on use of renewable energy, particularly solar and wind, to reduce energy cost. So, whenever there is a new upcoming project, the planning is done in such a way that there is a supportive renewable energy plant so that overall energy cost for the plant is reduced. Newer plant and technology has come forward for forward osmosis system. There are basically ceramic membranes which are now coming up. People have started using it for the ultrafiltration process. There are new developments in MVR based evaporation technology, and there are new innovations coming in the area of AI and IoT for real time monitoring and optimization. Each and every stage, from chemical dosing to sludge dewatering and to the flow management, there is an support system available on IoT business, which can help in quality monitoring, optimizing, and cost reduction. So these are the innovations happening in the satellite technology area. Now, if we talk about policy recommendation, there are basically subsidies and incentives for ZLD adoption, but these policies are different in different sectors, promoted by respective ministries, and different states have different policy recommendation. There are different enforcement of environment laws, promoting public-private partnerships in capacity building and awareness programs. So these are the key policy recommendations, but again, all these policy matters are different in different states or locations. What I can say is the future outlook would be there would be certainly a mandatory approach for all the water intensive units. If you are in a process of setting up an industry and you fall into the water intensive industries, then the state pollution control board or the central pollution control board won't give you the permission until and unless you adopt the Saturday concept. The growth of decentralized adult systems for small medium enterprise would grow up, because at a community project and to have large scales of plant, whether it is ZLD system or only common effluent treatment plant, it is difficult to operate and manage. So there will be a possibility of decentralized small and medium scale ZLD systems. Integration of circular economy principle in wastewater management. Circular economy concepts in the pipeline and water credit system has already started in India, and there are green credit system policies coming up, already implemented by the Ministry of Environment Forest. So all these are going to support this kind of project and initiatives. So these are the future outlook which I could see and share with you. So till here we have thoroughly basically uh, discussed about the concept of ZLD and CTP system. Now this was more on the policy front and the conceptual things. Now I am going to share with you the case study of our own common effluent treatment plant, which is ZLD system at Gujarat Eco Textile Park, which is located at Taluka Palsana in district Surat in Gujarat. Here we would be sharing you what sort of basically implementations, actions we have taken, and what has been our journey for adopting the ZLD approach, for adopting the recycle and recovery system approach. So now this is the case study. We have our CETP established having capacity of 60 mld with valid EC and NOC of 100 mld, having almost 80 members. All these members are associated with only textile processing. So we can say that this CETP and this park is catering only textile industries. The breakup is 27 process house around denim plants, yarn dyeing units, air texturizing, and technical textile units. So this is how the breakup is, and this is the layout of the park. On the top, there is a CETP and the ready plant situated. Every year, there has been increase in number of industries, and their contribution is shown in this pie chart, where maximum contribution is from uh, process house around 35%, denim 5, yarn dyeing 20, knitting around 35%, and other units are around 5%. In our park, this is our schematic handling 60 mld CETP with 25 mld UFRO ZLD system. If you see on the top, the effluent from the member industries is received in the receiving sump to the underground pipeline network. At the receiving sump, there is a screening system. There is a screening, and after the screening, the effluent goes to the equalization tank where the sedimentation process and effluent homogenization takes place. Then it goes to the sludge blanket clarifier where the physicochemical treatment starts, and from there the primary sludge is collected in chemical sump and sent for filter press for dewatering purpose. The primary treated water then goes to the pH correction and CTEC basin, which are mean for biological treatment. And after that, the partial water is treated uh, and discharged as per the PCB norm. And the rest of the water goes for recycling in ZLD plant of 25 ml. There, the first step is to subject it to ultrafiltration, then reverse osmosis, and then the reject is sent for crystallizer system with MVR. Here it is converted to salt. The RO permeate is sent to the member industry. So this is how the schematic and the system is there at our plant. Now, before we had to enter into the ZLD system, we had to streamline our member industries, because being a community driven project, you have number of member units, and these are small and medium scale enterprise. If they do not meet the stringent criteria for common effluent treatment plant, then it also affects the performance of CETP. And here the need is not only to achieve the CETP norms, but to go beyond to meet the criteria which can help and supports for recycle, recovery, and centrality system. So, as a first step, we have adopted an approach of working beyond the fence, because if you are a community project, if you are a common effluent treatment plant, then it is not sufficient enough that you only focus on CETP. You have to think beyond the fence. You have to work outside the fence. You have to start working from the source of generation to the member industry unit and at their premises. This is how we integrated and started our process. So this is a brief idea how we have, you know, uh, aligned with our member, how we have made them on board in this journey of recycling and ZLD at our CETP. So we started with them with the awareness campaign on cleaner production for water conservation. Now, why we had to implement this? Because we could see there is a change in groundwater pattern. The water table has increased from 30 feet to 100 feet, particularly in summer season. And if you want to have a normal borewell, you need to go up to 300 or 350 feet. So there would be change in TDS and hardness. There would be increase in water extraction cost. So it will also increase the CETP cost. So to decrease the pollution load, promote recycle, and ensure water saving measures, we had onboarded our member industries who are discharging their effluent to us. They had low technical know-how, they had low motivation and resource. There was a fear of failure on their part. So it was very necessary that we support them. So we formed the cleaner production committee, carried out water audit and cleaner production assessment for them. This helped them basically know that what are the areas that they can work and focus upon to improve their water consumption and also the wastewater generation at their own end, at their own premises. We worked out with a very simple designed checklist in line with the cleaner production assessment requirement. We formed a group. We continuously helped them through WhatsApp groups on regular basis, through mails and personal interactions. Appointed a full-time textile consultant. We appointed GCPC Gandhinagar to carry out studies for these units and provide them basically understanding on how they can improve on this area. We appointed FICI New Delhi for energy conservation and water conservation, supported by Shell, and this all helped us in achieving our recycling and settled system. These were the MOU signed in GCPC and Shell for CP assessment, and then there were series of training programs for water audits for cleaner production assessment at the CETP and the ZLD plant level. This kind of cleaner production checklist were created for textile units. We had find out through in-depth study that what are the opportunities where we can reduce the water consumption, where we can recycle and reuse, and where we can basically reduce the pollutant or contaminant by optimizing the chemical consumption. So these were the points that we identified. We shared and provide training, and not only that, hand holding with a full-time consultant to improve the water quality. So these were the implementations that we had, carried out. Very simple measures like tap size changing, cooling water recovery, condensate recovery, screen wash timer system, then replacement of water in the washing tank from first tank to the last tank and so on. Automation, particularly providing PLC system for UJet drying machine, drum washing machine, zero machine, then utilizing certain waste streams for scrubbing application, for basically dust control, for cold storage, recirculation of water in printing machine, and so on. These kind of initiatives we had implemented. Then water audits overall, machine wise and plant wise, the potential of water saving, and again classification on easy, hard, difficult measures we had worked out. And these are the actual implementations of different locations. At many places, unit have gone for automation. Uh, in drum machines, jigger machines, user dyeing machines. There are units who have implemented condensate recovery and caustic recovery plants. So ultimately, this helps in reduction in pollution load. This helps in improving the CTP inlet quality, screen washing timer, and other recycling in ETP. This is what we could achieve despite of increase in machine load, despite increase in new members addition. We were able to manage and control the water at our CTP inlet. This helped us in basically improving our water quality, consistent quality at CTP inlet. This is represented here in this pie chart, what and how the reduction has happened. Yeah, even we had worked out at machine and unit level. You can see the wastewater load reduction continuously despite increase in member units from 2015 from 35 units to 2022-23 around 80 units. We are able to manage our effluent load in the range of 35 to 40 ml. So to summarize on the beyond the fence, what we have achieved, we have achieved water conservation of around 4000 kl per day by adopting cleaner production, water conservation of around 8000 to 10,000 kl with RO recycling and ZLD system. Every day right now we are supplying around 10,000 kiloliters of water to our member industries through the ZLD plant. There is around 5 to 35% water conservation by individual industry at their own capacity level. There is an internal recycle at CETP. We are also using disposal of ETP sludge through alternate fuel facility to cement industries. And if we say the commercial saving for just year 22 and 23, it is in the range of 7 cr. 7 crores can be considered as a saving, where we have considered water cost at an average of 15 rupees per kl, which is border water cost, tanker cost of 50 rupees per kl, and working days of 315 days per annum. These are the achievements of working on beyond the fence on the member unit ends at the source, which helps us in improving the efficiency of the CETP and ZLD plant. Now coming on the ZLD plant having CETP. So what sort of challenges that one face at the ZLD plant or the CETP plant? The objective are basically improving the inlet characteristics. That's what the earlier exercise was carried out. Then second is improving the primary treatment efficiency, and then improving the secondary treatment efficiency. So the focus area, we carried out a lot of studies of electrochemical treatment, advanced oxidation process, improving different physicochemical treatment, so that the expected outcome could be reduction in color turbidity and BOD from the source of members, which we have addressed at the greater extent. Then improvement in TSS, BOD and COD. Then in secondary system, reduction of biodegradable content, different usage of different bioculture which can enhance with optimized aeration and use of DO set points to improve and increase the efficiency of biological system. So with this objective and challenges, we worked out those probable solution and started working on the CETP ZLD plant. We carried out different trials with different coagulants to optimize the conventional versus the natural biocoagulants, chitosan, and also the polyaluminum chloride. You can see various jar tests and analysis are continuously done. We had also involved external experts. We carried out a lot of studies, even including with Bhabha Atomic Research Center on electrocoagulation process and other optimization in physical, chemical, and biological systems. We standardize and optimize the COD reduction, the turbidity reduction in primary and secondary system in the range of 40% in primary and in secondary in the range of 80 to 85%. And these are those basically trials we carried out at individual plant level as well as the CETP level. We carried out studies for the denim units, those who are engaged in handling denim fabric in its processing. These are some trials for the dispersed dye streams which are generated from dyeing and printing units and yarn dyeing units using particularly synthetic clothes and dispersed dyes. These are again electrocoagulation trials for dyeing and printing units, and you can see the samples and the differences. So based on this kind of R&D and studies, we could basically optimize our physicochemical treatment, and then it was scaled up on CETP systems. Then there was a need of working on temperature. Temperature is one of the important parameter in biological system. Higher the temperature, there would be lower biological efficiency because the saturation of the DO is associated with temperature. So we optimized the temperature, and we are still working. We are still working in trying to improve on further reduction, and there are basically measures being taken. It is very important. Then ozone treatments at specific streams where we can address the refractory CODs, and different simulation trials and study on regular basis for optimization of plant performance. So way forward from this different studies and exercise, we could find that there is a continuous effort required for refining and retuning the physicochemical treatment and to make it optimized by replacing the lime and ferrous sulfate treatment, adopting the polyaluminum chloride. We could reduce the sludge generation, and at the same time we could achieve 40% of basically COD reduction, around 65 to 75% of TSS reduction, and around 40% of BOD reduction only in primary stage by adopting this option. By reducing in the temperature, we could increase our biological efficiency, and with conventional cyclic activated sludge system and MBBR, we could achieve 85% of biological reduction. Prior, it goes to the ultrafiltration and RO system. We were able to provide additional sedimentation tank based on the studies, optimization of DO, cascade cooling system, the additional fiber disk filtration, and UF based and RO based recycling and ZLD system. There are certain things which are indicated in yellow, which we are still working for further improvement and enhancement. And we are working on the phase 2 project activity when we are going for further expansion at our CETP and ZLD system. These are the glimpse and the photographs of our plant, what we have done. So we started with beyond the fence, working on the member industry. Then we have started working on our own plant, doing laboratory optimization, carrying out jar test, and optimizing our plant component for increasing the efficiency and compliance. These are the actual photographs you can see for temperature reduction, cascade cooling system, new pre-sedimentation tank, and additional uh, system for turbidity and color reduction. Here we are achieving additional 12 to 15% reduction. Dissolved air flotation and clarifiers, which helps us around 70 to 80% TSS reduction and 35 to 40% COD in primary clarification, and no usage of lime and ferrous. We have adopted turbo blower, which are centrifugal blowers with complete automation. It helps us in energy saving by 35% in our electricity bill. This has been successfully implemented since last 5 years at our CETP ZLD plant. And these are the photographs of our recycling ZLD plant. We have this plant designed, erected and commissioned by Suez, now taken by Veolia. These are the UF modules and the RO modules for 25 ml systems. If we see what are the operational parameters at different stage, in primary stage we are getting an inlet of around 300 to 400 TSS, COD around 1000, and BOD in the range of 250. The outlet we are achieving after primary treatment is in the range of 550 to 600 COD and BOD in the range of 150. After secondary, we are getting it COD in the range of 200 and BOD in the range of 20 to 30. And in the UF and RO, we are getting the permeate quality in the range of less than 350 ppm of TDS. These are the water quality samples, raw effluent inlet, then primary outlet, the secondary, and then last is the RO permit, a recycled water supplied to the member industries. These are the recognitions. The park has been recognized, and the water initiative beyond the fence, the cleaner production initiatives and water audit has been recognized by the CII and QCFI. So, if we summarize that, if we want to operate effectively our CETP and ZLD system, we need to integrate the source of generation with the community project, that is CETP or ZLD plant. We have to start with that. We have to do cleaner production, we have to do the water audits such that the hydraulic loading or the variations at the CETP or ZLD are minimum and it is homogeneous in nature. The organic loading at the CETP or ZLD plant is homogeneous and it doesn't vary. It meets the CETP inlet criteria norms. That is very, very important. And all the designed components in CETP and ZLD plant must achieve their maximum performance. For that, there has to be the evaluation, there has to be optimization, and there has to be continuous focus through the measures of jar test, through the measures of evaluation, and so on. So here we could achieve 80 to 85% of color and TSS reduction, 40% of COD and BOD reduction with the help of this new chemical approach, 35% reduction in energy consumption with turbo blowers, around 85% in COD and BOD removal in primary and secondary treatment, and the most importantly, ZLD system of around 12 MLD, which is recycled to industries. Every day we are averagely supplying 10,000 kiloliters of recycled treated water to the textile member industries, which is helping a lot in reduction in water footprint load by the approach of recycle and reuse. It is the approach of practicing and working of water stewardship and sustainable development. So with this, I'm concluding my presentation. The conclusion of all the three parts is that ZLD is not just a regulatory requirement, but a necessity for country like us, which has to ensure the water security, which has to manage the water stress, which is about to come in next 10 to 15 years. In the similar way, we are focusing on decarbonization. We need to focus on water conservation. We need to focus on improving the water quality and recycling and ZLD approach. The second is new innovation is in the pipeline. It is in continuous process, and new technology will definitely ensure basically enhanced throughput and a reduction in operational cost. Collaborative efforts are definitely required from government, industries, and all the citizens. And finally, sustainable wastewater management is the key to achieve the SDG 6, that is the Sustainable Development Goal given by the United Nations among the 17 SDGs. So, CETP and ZLD system and that approach is very essential, very important for a country like us, developing countries. And when we are in the process of development, have the sustainable development, we must follow and adopt community-based project of CETP and ZLD. Thank you. With this, I conclude my presentation. I would like to invite if there are any questions from your end.
Thank you, sir. Thank you so much for this presentation. There is a question, Dr. Rupali Goyal. Please unmute and you may ask the question. Dr. Rupali, yes, please go ahead and ask the question. By the time you may stop sharing your screen, sir.
Yeah, sure.
Okay, any other question? I guess she is unable to. You are already unmuted, madam, Rupali ma'am. I suppose she is unable to.
Yeah, not able to hear.
Yeah. Sir, is there any technology in tertiary treatment which is financially also viable? Because when we suggest industry for RO or ME, the only constraint for them is that capex problem.
Yeah. See, with new innovation, there are new approaches coming up. Like the new approach nowadays, which we are seeing at basically smaller levels, are related to MVR system. Here, if your TDS and pollutant load, particularly COD, BOD, if are at very low rates, you can go for adoption of direct mechanical vapor recompression system. Here, the operational cost is as low as 35 to 60 paisa. So it is very less per liter. So if we compare to the overall system, it eliminates your primary physicochemical treatment also. Yeah, but the part here is that yes, it is a capital intensive in the initial stage.
Yes. Uh, any other questions
Sir,
from
can
the
you highlight
participants?
something about the electrochemical wastewater treatment? Can primary treatment replace with this electrochemical treatment?
Yeah, 100%. As I said, we had gone into extensive study with Bhabha Atomic Research Center and their team on electrochemical oxidation and coagulation process. The very good results we could achieve was the color reduction. Textile industry face a lot of issues on color, dyes and pigments. We could achieve in the range of 95 to 99% of color reduction using this technology. The only thing is it is very good and beneficial at the smaller level. But if we want to go at the larger level, like our plant, common effluent, having 60 mld, which is very huge size, it is a little bit difficult for the scale up. But yes, at a smaller size, say you have 200 KLD or 500 KLD requirement, it's a good option, and definitely it has good result options available.
Sir, we have observed that electrochemical wastewater treatment is not a new uh, technique. It's a very old technique, fundamentally. The scale up and then implementation industrial level, uh, yeah, I think there may be constraint to adoption for the adoption of such a technology, because even in most new industry setups, they are not preferring the electrochemical wastewater treatment. What may be the reason, sir?
The reasons is basically for certain effluents, the what you can say, the suspended solids and turbidity removal is achieved, but at the same time, the organic reduction is not possible. And when we are having solvents and other salt residues in inorganic form, it is causing high maintenance cost, particularly the electrodes which are used in this process. The operation cost is higher. So these are the reasons. Having not necessary technical, acquaintance or knowledge, experience, and the high operational cost for certain types of effluent, which is a problem, not preferred by industries. But there are industries I have seen, particularly like some of the pharma sectors, they have adopted this electrocoagulation process. Zydus is one of the industry, they have adopted this. Not now, I would say almost 10 years ago.
Mhm. Okay.
Any more questions?
Nowadays, there are even newer approaches. Like if I would say, tanneries, particularly, are even adopting uh, radiation technology. Again, these technologies are developed by Bhabha Atomic Research Center. Many of the time, what the thing is, we are not basically having that awareness that what our own Indian institutes are doing the research work. These technologies are also provided by Bhabha Atomic Research Center at a very nominal cost. There should be a willingness to adopt those systems. There should be a willingness to participate in the study process and to find the best solution for you. There needs a cohesive effort, not only from industries but the technology supplier. As a normal layman, I would say that if you do some research and innovation and you want to make it uh, usable to implement, then there are 6 to 7 stages till you go to the prototype level. So here, those participation, hand holding, and commitment is required. If we follow those approach, definitely we are having lot of solutions which we can have.
Yes, sir.
Okay. So, dear participants, do we have any other questions or any other interactions? There is one question from Yagnesh Pandit in the chat box. Sir, kindly share the machine-wise standard water consumption which you presented in the slide, textile machine-wise water saving potential study.
Sure. Uh, Definitely, I'm going to share the presentation, and you can get those data from Mr. Rotliwala and Mr. Taylor.
Okay, sir. Thank you. So I suppose we shall conclude here. Thank you so much, Ashish sir, for your valuable time and presence. Okay,
Thank you.
and
Thank
yes,
you,
sir.
Ashish bhai. Thank you.
Thank you.
Okay. And dear participants, I will be sharing a link at 6:30 p.m. for the final conclusion of online test and reviews. So please make sure that you fill this link and you attempt the MCQ based questionnaire for procurement of Atal certificate. Thank you so much. At 6:30, I'll be sharing the link, and at 7:30, we do have the valedictory session, wherein, as I told you yesterday, that Dr. Sachin Parekh, the Joint Secretary for Technical Directorate of Technical Education, has consented to join our meeting as a chief guest. So please be present at 7:30 as well. Okay. Thank you so much. I'm sharing the link for the MCQ exam straight away. I'm not waiting till 6:30. I'll be sharing it right now. So please attend that link and do join here by 7:25 sharp. Thank you so much. Please mention the email address and mobile number and your name, same as that you had mentioned in the Atal portal.